Next question we have, this is from carbohydrate chemistry, and in examination point of view, carbohydrate is a very important topic because it's having importance biologically. So because of that reason, this is very important. And so here we have two options. Here we have A and B, and here the product we need to identify what is the product here. So before going to the answering this question, we need to know about the anomeric effect. This is also called as polar effect. So what it tells? So when we have the carbohydrate like this, and when we have any group, let's say imagine X we have, and if this is having a lone pair like this, and further what will happen, there is a lone pair with oxygen also, and there will be repulsions between these two lone pairs. Okay, so this is called anomeric effect and polar effect. So because of that reason, so this will not be favorable. Okay, so what is favorable here is the axial attack will be favorable. So sorry, here we should not call axial and equatorial. This is alpha attack, alpha phase we can say, and this is beta. So this attack will be favorable compared to this. Okay, this we need to see. This is called anomeric effect. And if you see in this case, so this is simply substitution so here the mechanism will be like this, what we say yeah. So in this case, the first step is the protonation will takes place. The protonation will takes place on this oxygen, and now it will become like this. This is OAC, and here we have OAC and OAC, and this is also OAC. And here the position is not fixed here. It can be like this or it can be downward also. So this is OACH. So why we are doing protonation here? Generally OME or OAC, these groups are not that good living groups. Okay, so if you want to remove this one as a living group, we just make them as a this form, then only we can remove that. And now, so this goes, and the lone pair which is present on oxygen, that lone pair comes this way, and now this will become OAC, and this is OAC, and here also OAC, and here we have double bond and positive charge. Okay, so next, so here from the HBr we have already consumed H plus, and Br minus is there. So that Br minus will attach to this double bond. This is OAC, here OAC, and here also OAC. And this there are two possibilities we have. So this can attack axial attack this way, or this can also attack this way. I am not writing these groups. And as I said that bromine is having a lone pairs, and also the size of the bromine is very big, and here also the lone pairs are there, so there will be dipole interaction. This is only we call as a anomeric effect. So because of that reason, this will not be the possible. It can be formed, but it will be forming the less amount. The maximum amount which forms here is axial one. Okay, now so the first this is the A product. In the second product, in the B, so we are treating this compound with the methanol in the presence of AgNO3. Okay, so this is simply the SN2 reaction. This is simply SN2 reaction. So here we have a bromine in the axial position, and whatever the nucleophile is coming here, OMe here, that comes from the equatorial position. So this bromine leaves this way. In the final product, what we will get is here this OAC, and here also OAC, and here the bromine is going this way, and means axial way, and the methoxy group will come equatorial way. Okay, and here this is SN2 reaction that we keep in our mind. So here we can't talk about the anomeric effect. Anomeric effect, here we can't talk about anomeric because this is SN2 reaction. So SN2 reaction means like if the leaving group is going from this way, the nucleophile will come this way. So this is about this question. So this will be the option B, sorry, answer B. And then and here we have another question, the major product formed in the following sequence. So this is also very simple question. So 4 options I have written here. I think you can see that 4 options I have written here. So in the first step, this is very simple. This is the Ramer-Taymer reaction. So in the Ramer-Taymer reaction, we know that alpha hydroxy compounds will form. Sorry, alpha hydroxy carbonyl compounds will form. So I am writing like this, OH, and here we have CHO, and here a methyl group. Now we know that H2O2 in the presence of NaOH. So I have made a video on the boron chemistry. There I have explained this one. Okay, the base will take one hydrogen and it forms O minus OH. Okay, and here we have electrophilic center. So this is hydrogen CHO. So this is the electrophilic center. So this O minus comes and attacks to this electrophilic center, and now it will become like this, OH methyl group C O minus OOH, and here we have a hydrogen. Okay, in the next step it can be this OH can be OH will be eliminated, and this double bond comes like this, and this oxygen, like it gets migrate. We can call it as a 1-2 migration. No, we cannot call it as a 1-2 migration. So this O goes from this position to here. So now it forms like this, OH, and methyl group is here, and here O, and then aldehyde. Okay, now so whatever the OH minus left from the reaction, that OH minus comes and attacks to this carbon again, and this double bond comes this way, and this will become like this, OH, and methyl group is here, O, the O minus here, OH, and H. Okay, so now we eliminate this one as a carboxylic acid. Sorry, now this will become OH, and this will be O minus, and this will be methyl group, and here we have a C double bond O, OH, and H. So this is the one which is coming from here. Okay, now this is the O minus. So this hydrogen, this hydroxyl hydrogen is very acidic, as we know that this hydrogen will be abstracted by this negative charge. The final product what we will get is here, this is OH, and this is also OH, and this is methyl group. So this is the final product here we'll get. So if you see the answer, the B is the correct answer. Okay, it's a very simple question. If you know this one, and here we should know about this migration also. If this oxy insertion, if we can call this one as a, we cannot call it as a migration, we call it as an insertion, because oxygen is inserting here. So this step you have to remember. If you remember this step, then it's very easy to identify the answer. Okay, so if you have any doubts about these questions, you can comment in the comment box.